Hello and welcome back. In order to understand assembly language programming, you will need to know the binary and hexadecimal number systems. So in this lecture, I'm going to briefly talk about those. Base 10 decimal number systems. Traditionally, we are using base 10 decimal number system, where we use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to represent numbers. There is also something called the base 2 binary number system. Computer hardware understands only two symbols, 0 and 1. 0 is low voltage and 1 is high voltage. Everything in the computer memory and hardware is therefore constructed from zeros and 1s. Using only 0 and 1 is called the binary number system or base 2 number system. In base 2, we only use two digits, that is 0 and 1. Now we can compare this with base 10 where we use 10 digits. In addition to that, we also have base 16, also known as hexadecimal number systems. In base 16 number systems, we use 16 digits to represent numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, where A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. Now, if you need to know further about these number systems, I give you two references which are quite useful. The first one is where it shows you a table of the conversion between the various number systems. The first column is your decimal number, the second column is your hex, and the third column is the binary representation. So as you can see here, in the decimal column, it increases from 0 to 1, 2, 3, all the way to 9 and then 10. And then in hexadecimal, 10 is represented by A, and in binary is 1010. And as you can see in binary, the increment is from 0, 1, 2 is represented by 10, 3 is 11, 4 is 100, 5 is 101, and so on. And this can go all the way from, for example, if it's 15 is F, and in binary is 4 ones. And then if decimal is 16, hexadecimal is 10, and binary is 1 followed by 4 zeros. And then if it's in decimal is 17, in hexadecimal is 11, and in the binary is 10001, and so on. And you can see this table goes all the way and then continues after 63. It continues here, 64, and then in hex is 40, in binary is 1 followed by these 6 zeros. And then 65 is hex is 41, and binary is 1 followed by 5 zeros and 1 1. So this can go on like this all the way to 127, and then continue here 128. Decimal 128, hex is 80, binary is 1 followed by 7 zeros, and goes all the way until here 191, and binary in hex is BF, in the binary is 10 followed by 6 ones. After 191, it goes to 192 and all the way right until 255. So 255 is FF in hex, and in binary is all ones. So this table only goes from 1 to 255. Now if you want to convert larger numbers than other than 255, you can use your programming calculator. So let's go to the programmer calculator. Right click at the bottom here, click search, and key in CALC calculator, and you will find it there. By default it's a standard calculator, so just click on this hamburger here and select programmer, and now you have programmer calculator. And as you can see here, you have hexadecimal, decimal, octal, and binary, but we are not concerned with octal, we are just concerned with hex, decimal, and binary. And you can click here to select the default input. Let's say we want the default input to be decimal, so you click on this, and you can click 1, and 1 in decimal is 1 in hex, and 001 in binary. And then let's say we delete this, and if we put 10 in decimal will be A in hex, and then in binary will be 1010. So you can compare that with the table here and see 10 is decimal, hex is A, and the binary is 1010. And then if you, let's delete this, 11 in decimal is B in hex, as you can see here, 11 decimal B in hex, and binary is 1011, and you can see here binary is 1011. So if you want to input a very big number, let's say you want to input 1456 and so on, so in decimal is 1456, in hex is 5B0, in the binary is 101 1011 0000, and this allows you to convert numbers bigger than 255. See that? Now another way to convert numbers is to use your Hexadbg itself. So let's fire up Hexadbg over here, and then over here you have a calculator. See that? Click on that, and then you can convert numbers here. So go into the text box here under sign, and key in 1. So 1 in decimal is 1 in hexadecimal, and in binary is all zeros and followed by 1. And then what about 10? 10 in decimal is A in hex and 1010 in binary. Okay, and then how about another number? Let's say big number 2355. 2355 in decimal is 933 in hexadecimal, and 1001 0011 0011 in binary. So you can use this as well to do number conversion. If you wanted to know what is the theory behind these number conversions, then I have a good reference for you, Khan Academy free lessons on binary and hexadecimal system. So head over to this free resource, free lessons. You don't have to sign up for anything. You can just go there and learn, have a refresher course on binary and hexadecimal number systems. So this will tell you exactly how a conversion is done. But for fast conversion, I would prefer to use just the calculator or the calculator up here. That will be much faster rather than trying to manually convert numbers yourself. But for background understanding, theoretically this would be quite good. Why do we need hexadecimal when we already have base 2? The reason is because hexadecimal saves space. For example, when you want to represent big numbers, you can use A, B, C, D, E, F. So this makes it easy to represent big numbers in a compact manner. And binary is difficult to represent because, as you can see, if you were to open your Hexadbg, if let's say I load the program, now all this is actually hexadecimal. If you wanted to represent this in 101010s in binary form, it would take up a lot of space. It would take up a huge amount of space. So that's why we use hex. Hex is compact. So A3EC0C, you can easily convert it by using your calculator here. Key in A3EC0C, click on hex here, and you can key in the A3EC0C, 0C, and that will give you, binary is this long number, and if you want to put this long number here, it will take out a lot of space, and it's difficult to recognize the pattern as well. And also in this hex format, it so happens that every 2 digits is considered as 1 byte. So EA is 1 byte, AE is 1 byte, 01 is 1 byte, 0C is 1 byte, and so on. So that is what makes it compact and easy to recognize patterns. That's why we use hexadecimal, and we don't use the binary representation in here, although these are actually binary, and the machine level is all binary. There is no such thing as hex. Okay, so that's why we need the hexadecimal number systems in assembly programming. So that's all for this video. Thank you for watching.